Okay, in this lesson we want to use the Pythagorean theorem, which we know is a squared plus b squared equals c squared, and actually apply it to a right triangle. Because, excuse me, we know in a right triangle this property works. And we have to remember back that the longest side is opposite the right angle, which in this case we always want to refer to as c, which is also the hypotenuse. So that is the longest side. Hypotenuse, there we go. And then my other sides are the legs, alright? So they are A and B. I could flip those, it really doesn't matter which A is and which B is. So, if we go ahead and have any right triangle, so we'll take this one, there's my right angle, and what we're going to do is solve for the hypotenuse. So what happens when you get questions where we don't know what the longest side is or what the diagonal length is of a rectangle, so to speak? Because that's essentially what this is the Pythagorean theorem is essentially figuring out what the diagonal distance is of any rectangle. So let's take a look. So we'll just pick some numbers here. Let's put in 7 for one of the legs. Let's put in 12 for the other leg. It doesn't really matter. So we use the Pythagorean theorem, which is a squared plus b squared equals c squared. We know that 1 is a, 1 is b. It doesn't really matter. And we know that the thing we're trying to find is c. So what I'm going to do is substitute in. So we'd have now 7 to the second power plus 12 to the second power equals c to the second power. So now this is an equation. We do want to solve for c by itself, but let's do some simplifying first. 7 to the second we know is 49. 12 to the second we know is 144 equals c squared. So I can combine 49 and 144, and that's 193. But here's where you have to pay attention. I'm not done solving this equation. We now know what c to the second power is, but we don't know what c is yet. So here's where we have to take a little bit of a step. Ask yourself, what undoes addition when solving equations? Oh, that's right, subtraction. What undoes multiply? Oh, that's right, divide. Well, here's another operation. What gets rid of an exponent of 2? What's the reverse of squaring something? Well, let's think about it. 8 to the second power is 64. What do you do to 64 to get back to 8? Hopefully you're thinking to yourself, that sounds like a square root, Mr. Long, and you would be correct. So square rooting undoes the square of a number. So in essence, what we're doing here is square rooting both sides of my equation. So here's the 193. I'm going to square root that. And what does this leave me with? Oh, well, it leaves me with the square root of c squared is c. And my answer is the square root of 193. And what you're going to get is a messy decimal because the square root of 193 is an irrational number, which means it's a decimal that never repeats and never ends. So for our purposes, we're going to round it. It's 13.89. And put a wavy equal sign there. It depends what the question's asking for, what you have to round things to. So let's go back up to our problem and make sense of this. So let me clean some of this up real quick. And let's remember a few things. In a right triangle, my legs are the shorter of the 3 sides, and my hypotenuse must be the biggest. So, does this answer make sense? If I put it back in my picture, is it still true that my hypotenuse was my biggest side? And the answer is yes. 13.89 is bigger than either 7 or 12. Okay, so this is how you solve for hypotenuse. I'll go a little faster with it. Let's put 5 here, 8 here, and we want to figure out what the hypotenuse is. So a squared plus b squared equals c squared. 5 to the second plus 8 to the second equals c to the second. 25 plus 64 equals c to the second. So what's that? 89 equals c to the second. My last step is to square root. And square root of 89 is 9.4 with a bunch of extra decimals after that. So that's my longest side. Go back up, double check, make sure it fits. Is 9.4 bigger than either of the other two sides? Yes and yes. Alright, so this is how you solve and figure out what the missing hypotenuse is. This is how you solve for the missing longest side. Oh, and let's do a fun check just because. Does this work as a triangle? Well, triangle inequality theorem, does 8 plus 5 give you a number that is bigger than the longest side? Well, 8 plus 5 is 13. Is 13 bigger than 9.4? Yes, so it is a triangle. Plus we found the biggest side, which is the hypotenuse, using the Pythagorean theorem. Okay, so for today we want to build into our triangles Excel. Just a reminder, we had triangle inequality theorem, does it work? And then we had triangle inequality theorem, you only know two sides, and this will find the range of the third. And then we started with Pythagorean theorem, where we just set it up to see if it works. Take my two sides, my shorter sides, my A and my B, which are my legs, and I could probably actually put that up here. Leg, hypotenuse. And we had it set up to say, yes, it's a right triangle, or no, it's not, because this worked. A squared plus B squared equals C squared. So I'm going to scroll down a little bit. I'm going to add in. We actually want to now calculate for the hypotenuse. So I'm actually going to copy this stuff, Control C. I'm going to go down here and Control V. And I'm going to delete these out because we don't know them yet. And we actually want to put a formula here so that it will figure out what the hypotenuse is. So if you watch the video before this, we figured out that if I do a squared plus b squared, put those two values in, square them, add them, and then my last step is to square root that number, and I will get my resulting side. So let's go ahead and do that. I'm going to start off with equals, and what we need to do is square root that final answer. So I'm actually going to kind of work backwards with this. I'm going to set up my square root first. Square root, it's been a long time since we've done it. SQRT. SQRT. I'm moving my mouse out of the way. SQRT. Parentheses. What are we square rooting? Well, we're square rooting the two side lengths that we squared and added up. So let's now build that part in. So I square root the answer of this raised to the second power, which is shift and 6 to the second power, plus side B, which isn't it let me do that? Nope. So I can't click there for whatever reason. Maybe I don't have room. So I'm going to I'll just type in B, what's that, B15? B15 to the second power and close my parentheses. So that's basically what I was doing, is I squared the two side lengths and then added them up and then took that final answer and square rooted them. So hit enter and I should be able to do that. So I'll pick some that I know work. So like I can now, what if I have a 3 and a 4, but I don't know the hypotenuse? 3, 4, 5. And I could go back up here and prove that it works. 3, 4, and 5. Yeah, that's a right triangle. So we now should be able to change these two out, change the leg sides out, and it'll automatically calculate what my hypotenuse is. Okay, simply by square rooting the sum of the two sides, the sum of the squares of the two sides. So another one, I could do 6, 8, and it should give me 10. Let's pick random numbers. Oh, and by the way, this is bigger than either of these two, which makes sense because it's a hypotenuse. So let's try like 12, 24, sure. And you'll notice it'll give you a decimal answer. So use this, get this set up in Excel, and then use it for Excel, or IXL, I should say. Just take the two sides you know, and it automatically calculates out what your hypotenuse is. All right, so by this point, your Excel should look like this. All right, these two were my triangle inequality theorem, and now this is the second part of the Pythagorean theorem, solving for the hypotenuse. And if you want to label this stuff, you can. Okay, I mean, I'm not going to right now, but you can. So this is what you should have built. All right, good luck.